without having to worry about using a parent function. And the way we use it, hey, what's going on? Don't mind the play. You're talking to. The other way that it goes about is by utilizing the coefficients prior to pulling out the value of b, like we did yesterday with the sine, cosine, and tangent. If you guys could have seen her face, she's like, holy crap. So what we were doing yesterday is when we had our y equals a sine of b x minus h plus k. You guys had a couple of problems where you had that b value thrown in here. And in order for us to figure out anything with it, we were taking that value of b out. Okay? So when you're taking this out, you're dividing out by the b, so you're bringing it out of both of them. Excuse me. So that's where they're getting another way of writing this out. What they're using is a more simplified, it says it's simplified, but it's going to look weird at first, but you do it a couple times and you're saving yourself that whole parent function graph. It forces it right to your new period, all that stuff right away. So you have a sine bx minus c, and it's the same thing for cosine. Yeah, I did. Your excuse me, your amplitude, your a value stays the same. Your period is still going to be that b value. Notice the value of b, instead of pulling it out, we're still using that same coefficient. So like the one you were saying earlier, Sid, where we had, it was like pi over, it was 1/2 x was inside the parentheses, or something like that, where even if we pull that out, that's still your value of b. So b, instead of doing that extra step, we're leaving it where it is. So we're just taking this right off of that. You're still going to get the same period, but like I'm saying, it's going to make it easier for us by not having to print out or draw out the parent function and then go to that extra set of 5 points. No, because the h value is going to be different from algebra 2 now. The h value from when we did the h's and k's in algebra 2, every single function that we did, we had a parent function that threw to some sort of a shift, some phase shift. And by keeping it that standard form with h and k, it kept you guys buying it, if you will. You knew what it meant every time, whether it was a square root function, logs, exponentials, conics. We had the h's and k's and conics and things like that also. Every one of those was the same. You knew horizontal, vertical. By throwing it this way, it's taking away that extra step of the parent function. Because what we can do is that we're going to get the cycles by solving those two simple equations. When we take this and we set one of them equal to 0 and the other one equal to 2 pi, that'll tell you where your breaks are going to be on your graph. Oops. Instead of starting at 0 and going out to something and then shifting it, it's going to tell you right away where to start and where to end. So we don't have to worry about doing that phase shift. We can plot directly to the function without having to do a parent. It's quicker. All right? It's quicker because when we did I showed you guys what this is going to look like when we do the inverse function. If we do a sine graph, 0, A, 0, opposite A, 0. If I want to look at cosecant, that's the inverse of sine. What's the inverse of 0? Undefined. 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 And then we'd have to plot the parent, plot all those undefined points, and then plot everything else again. We'd almost have to do 3 full graphs for this, for an inverse function with h and k. Whereas if we do it with this a, b, and c stuff, it's just plot it directly with the shift and then draw asymptotes. So by using this ABC method, it's just saving us time. And I know you guys are, busy and you got things, and well, not you.
I was going to say.
Not you. You know that. So when we look at one, we're going to get this. Let's start with something easy where your b value is going to be 1. And I'll show you how this works out. Y equals 1/2 sine parentheses x minus pi over 3. And we're going to plot it directly into its own phase shift, in its own shifted graph. Yes, sir?
Wouldn't that just, like, the one that you have before, where it's just changing the period?
Yeah. And what this allows you to do, jump right to the period of the shifted graph and you don't have to do the parent. Okay. So what we were doing yesterday was an exercise more in making sure you guys remember how to add and subtract pi over 2s and things like that, and how to get those breakpoints, because it is useful to know where things are going to wind up, so you can just plot it and be done with it. Okay. So we're becoming more efficient today. Yay. So let's see, let me bring this back over. We have both sides. I'll show you this. Just get this off the side. So we have y equals 1/2 sine x minus pi over 3. Obviously, our a value is 1/2. So our amplitude is going to go up to 1/2, it's going to go down to -1/2. That's pretty easy, that doesn't change. Our b value is 1, it's the coefficient of x. The c value is pi over 3. So the left and the right endpoint for the period are going to be at 1x minus pi over 3 equals 0, and 1x minus pi over 3 equals 2 pi. What's that? I just put the a value here, so it's just because it's the the b value. So bx is you're going to solve both these equations for x to get your shifted period. Yes, sir.
When you do it in tangent, are you gonna the other equation? Are you gonna
Yeah, it's finding you your endpoints of your shift right away. So your endpoint is going to be on the left side would be at x equals pi over 3, and the other one would be at x equals, let's see, 6 pi over 3 would be 2 pi. Add a pi, you get 7 pi over 3. Are we okay with that? Now you know your endpoints for your period is for the shift. Move this up a bit here. I'm not going to start at 0. I'm going to start at pi over 3. And I'm going to end at 7 pi over 3. Now when you're finding your other points, throw pi out of the problem for right now. I'm going to take half of 7/3. And what do you get? More pressure.
Oh, I think I just
7/6. So it'd be at 7 pi over 6. What's that? That's half. What's half? When you had at 0 and pi. Isn't that the halfway point?
Yeah.
Oh, yes, I see what you're saying, yes, I done goofed on that one, thank you. Okay. So here is your full period, okay? What's gonna be halfway between 1/3 and 7/3? Thank you, I see what I did, I see what I said there, yeah. Watch what happens. We're gonna find a midpoint and then cut it down. This is midpoint. You're finding a midpoint. Yeah. Thank you. I didn't realize I had said it that way. So what I'm saying here is, if I do this, those are endpoints of a segment. What's the midpoint? Add them together. Add them together, you get 8/3, and half of that would be okay. Does that make sense? It's the plate. It's probably like 3 remaining brain cells. And then I do the same thing for between 1/3 and 4/3, and 4/3 and 7/3. Okay. I'm taking the pi out of it to get those breakpoints. That way I don't get lost with all that pi. Okay. So if I do that again with 1/3, be 5/3. So 5/3 times a half would be at 5/6. And then you know, 11 pi over 6. And those are your ordered pairs. Now, obviously, thirds are awful. Fourths, halves, things like that, those are the easy ones. Thirds are, ugh. Okay? Values of A was positive, wasn't it? Sign, it still starts at its first spot. So it's going to start at the 0 value. And just move up. And there's my graph right away. It's already correct. And the whole idea of it this way is that by doing those breakpoints right away, when we go to graph, if this was a cosecant, I still have to graph the sine graph first, which I could do quickly, and then I just draw up my asymptotes and flip my curves. It just makes inverse functions so much easier to do it this way with the A, B, and C. Okay. We're going to do it with the regular ones first, and then probably tomorrow we'll start graphing the inverse ones tomorrow. Okay. Let's try it on. Excuse me. We'll do the same method with the cosine graph. So we have the line, it's A cosine. And those would be our 2 breakpoints for the period. So A is -3, B is 2. So our period is going to be 2 pi over 2 pi, which is 1. Okay. So we set our equations up. subtract 4 pi divided by 2 pi. And then same deal. Oops, that break 4x, 4 pi, sorry. You set it to say it's the bx minus c. It's take that.
Okay, so like if it's positive,
Yeah, because if you think about if we did it our old way with the h and k, if I factored out that 2 pi, I have a plus 2 pi, which means I'm moving it to the left.
okay.
And you see where my endpoints wound up at -2 and -1, which means I still move it to the left.
Okay.
All right. And I know my period is 1. What's the distance between -2 and -1? 1. Drag it. So let's set it up. I should probably make this a little bigger so we have a little more space. What's halfway between -2 and -1?
3.
With what, -5/4, and then -7/4, if I'm not mistaken. And cosine was a -3. Now, do I start my graph at -2 or do I start it at -1? Start at -2, because that would be your first spot. Okay. Cosine A value is negative, so I start at +3 or -3? -3, work your way through. Not bad, is it? See how it's a little bit quicker than parent function shifted? I think a lot of teachers have given up on sending people out for target classes.
You're missing more class than you would have.
Then you should take it back.
Should we do a tangent?
Wait,
Yes.
what if there's a kid though? Like,
Yeah, we've never done
you just don't have
If,
kids.
if you look at a lot of the stuff that we have, not a lot of case thrown in.
Even then, you could just shift it up again.
Right.
It's not hard.
Right, and that's usually what happens when it's tail down at the very end. You just take those and you move them. You do the you do the ABC method right away, and you know where those are. If there's a +3, you just move these up 3. So that your vertical shift is easy. You don't have to worry about it because the ABC is still going to let you do all this stuff first. So let's look at a tangent. Since you were asking if you said equal to pi, you're going to set equal to pi over 2 because that'll get you to your afterwards. Okay. So when we're doing this with tangent, it's the same principle, except instead of equaling to 2 pi for the full oscillation, you're going to set it equal to where your asymptote's going to go. Your asymptotes would be, if you were at your origin with the regular pi period, would be at pi over 2, negative pi over 2. So you set those to be your endpoints, find your asymptotes, and then work your way out of that. So tangent, same deal. If it's y equals a tangent dx minus c, it's just a matter of setting them through. So I'm going to get to the example that I had. I wrote this one down. So let's do this. You know, let's do it. Let's put a 2 out in front of this. Let's make it interesting. Negative 2 tangent of parentheses 2x minus pi over 2. So, in doing this like we would do normally, oops, a little too far there. I know that my a value is negative 2, which means the tangent graph's been moving down and to the right. My b value is 2, which means my period is pi over 2. I know that from before. It doesn't change. To use that a, b, and c method to go directly to the shifted graph, we take our 2x minus pi over 2. We set it equal to negative pi over 2. And 2x minus hello. And set it equal to pi over 2. And those will give us our 2 vertical asymptotes. And then what occurs halfway between the 2 vertical asymptotes? You go through the origin part. Okay? You go through that origin part. And then you get your halfway points, you get your points of inflection. So if I add pi over 2 to a negative pi over 2, I get 0. So I have one asymptote at 0. And then the other one, I have 2x equals pi. So it'll be at x equals pi over 2. If you look at your period, between 0 and pi over 2 is our period, pi over 2, so we've already figured that out. And now it's just a matter of plotting it through. So you find your asymptotes first. Zero and pi over 2. What's the halfway point between those two? Pi over 4. There's your break point. And then it'll be at pi over 8. And 3 pi over 8. Our a value, all the way up here, was negative 2. So if the a value is negative, it's working its way down and to the right for the tangent graphs. And there's our tangent graph. So it's just a lot faster to graph it with that A, B, and C, as opposed to it was with the H's and the K. All right. Hopefully that wasn't too scary. Sir?
How come people say equal pi? It's just the whole thing.
pi would be would be your overall period. But when you have your regular tangent graph, that distance was pi. By doing it to the pi over 2, negative pi over 2, you're going to be able to find where these are being placed, which will still allow you to get that period. It finds you the asymptotes that give you the period, whatever this is. So it's telling you where the shifted asymptotes were going to be that give you a period at pi over 2. So we found our asymptotes were at 0 and pi over 2. Well, the distance between those is pi over 2. It's a nice little, it's a kind of a shortcut way of doing it, instead of having to add all that stuff together with the h's in the case. It's just a little bit cleaner. All right. Not bad? All right. We'll give you a couple of these to do. I want you guys to try with this method of doing it before we get too far with the inverse ones. Let's see. So in 4-5 on page 329, let's do 45, 46, 47, and 48. Wish there were more tangent problems. And let's see. Since the book doesn't have enough tangent problems, I just made those two up. Hopefully they work cleanly. Probably won't, but whatever. Okay. So I give you 6 graphs. Use that A, B, and C method we did today. I want you guys to try and go right to your shift, and you might be pleasantly surprised that it is pretty quick and painless. Okay? Please and thank you. No, just look at me.
Cindy's not here, and Cindy gets everyone in conversation.
I was gonna say with Ben, but yeah.
Pretty close, but I think the top one.
And Jeff.
Well, it's not so. Jared wasn't bad. He just would come up for air every once in a while. Wait, what?
No, that's because you have to sit.
That's true.
Like everything you did up there, you get a comment on, like ask me how, or, I don't know.
He was being.
I would like listen to what